Hello everyone, this is the video tutorial for Instrument Lab 4. In this video, we'll cover the goals of the lab as well as tips and tricks for great data. The goals of today's lab are to check scanner head calibration, to determine the radius of the probe tip, and to determine the stiffness of the cantilever. Part 1. Scanner head calibration. Most scanners have trouble zooming properly. In this first exercise, you'll zoom from a large 60 micron scan to a small 5 micron scan. When choosing an area to zoom, choose a spot off-center. You will do this twice. This is because of the time dependencies of the zoom head. Usually, the second zoom is more accurate. A good example of a zoom choice can be seen below. You will be using the grading TGT11. The specs for this grading can be seen below or found at NaioAFM. The parameters for this experiment are as follows. You will scan at a high scan speed in contact mode. In order to get the full 60 micron scan, you need to rotate the scan direction by 45 degrees. An example of how to do this is to the right. Remember to zoom in one of the four corners of the large image and to do this twice. Part 2. Determine the tip radius. In this exercise, you'll change the sample from TGT11 to TGT1. This is a delta function grading. The sharp spikes will allow you to image the tip. You will begin with a 5 micron scan and then optimize the image. After you've done this, you'll zoom in onto one spike. The sample parameters you will use are listed below. Again, you can go to NaioAFM to print these out yourself. The parameters for this experiment are as follows. You will first scan at medium speed with a scan range of about 5 microns and then optimize the image. Here, we have a quick and efficient tip for image optimization. You will change the aspect ratio of the scan so the probe moves over only one line. To do this, we need to go to the SPM parameters window. Here, you'll uncheck the box between X star and Y star. In the Y star box, you'll enter 0 microns. Now you'll move over only one line. If your line does not correspond to a feature, use the offset boxes to move until you find one. After you're happy with your optimization choice, return to a square aspect ratio of a scan range of about 1 micron. Part 3. Determine the spring constant. To determine the cantilever stiffness, we first must measure the resonance frequency of the cantilever and find the manufacturer's information for its length and width. Once you have this information, you can input it into the equation below. Values for density and elastic modulus are also provided on this slide. To find information about the cantilever, you must go to the acquisition bar and select the cantilever icon. Here you can scroll through the information until you find your cantilever and record its data. To find the resonance frequency, you first need to withdraw the probe from the sample and change from static mode to dynamic. Then you will press the frequency sweep icon and take note of the vibrational frequency. Don't forget to recall older techniques such as flattening the image by using the slope function, and choosing good parameters for image optimization. For review of these concepts, see earlier tutorials. In summary, remember that we're using two samples. Don't forget to withdraw the tip when switching samples. There are a lot of different experiments to do today, so move efficiently but stay organized. And don't forget to have fun.